Right, so the final worked example that we have on projectiles, eg10, is a vector form. And as I mentioned when we looked at the vector form of the horizontal projection, often this is less work than when they give it you in terms of an initial speed and an angle of projection. So a ball is struck by a racket at a point A, which is 2 meters above horizontal ground. Immediately after being struck, the ball has velocity 5I plus 8J. After being struck, the ball travels freely under gravity until it strikes the ground at a point B. Okay, so we've got this point that's above horizontal ground, and we've got that it's being struck with a velocity of 5/8. So the horizontal component is 5, the vertical component is 8. The thing then flies off before coming to land on the tennis court, I suppose. And where it lands, we know that it's going to have a horizontal position, which we don't know is X, but we know the vertical position. So R at this point is going to be X, we don't know, and it's going to be minus 2J, because that point is 2 meters above horizontal ground. And at this point, because we're going to want to know the speed of the ball when it reaches B, so this is point B, this ball is going to be moving, and I've cocked up this diagram because I've written where. So we're going to want to find the speed that it hits the ground with. So Vx I know is Ux, Vy we don't know. But I'm not doing this in terms of Vx and Ux, I'm doing this in terms of V, in vector form. So V is going to be U, the horizontal component of U, and the Vy bit we don't know, because remember, in the horizontal component the horizontal part of the speed doesn't change because it's not affected by gravity. But before we get there, we're interested in the maximum height, and we know that at the maximum height, at max height, Vy equals 0. And we know that Vx equals 5. So at maximum height, the velocity is going to be 5, 0. Right, so the greatest height above the ground reached by the ball. Well, above the point of projection, we know that at that max height, Vy equals Uy plus Ayt. Vy is 0, Uy is 8 minus 9.8 t. So the vertical component is 8, and the vertical component of acceleration is minus 9.8. So t, the time at the maximum height, is going to be 8 divided by 9.8, which is 40 over 49 as a fraction. So they're not asking us for the time, so we can leave it as a fraction and use it. So we want the vertical displacement, Sy, equals Uyt plus a half Ayt squared. Sy is 8, 40 over 49 minus 4.9, because AY is minus 9.8, 40 over 49 squared. So I've substituted in the value of t that I've just worked out from the first equation that I've used. So if I just store that in x, then I can write 8x minus 4.9x squared. 3.26 5 blah 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 blah, which is 3.3 meters to SF, but that's 3.3 meters above the point of projection. So that's above point of projection. Therefore, there's another 2 meters to add on to that above the ground. So that's the height above the ground. Okay, the speed of the ball as it reaches B. So when it reaches B, I know its position, its vertical position, is minus 2. So speed at B, well, I know the Vx, the horizontal, is Ux, which is 5. So I need to find Vy. So if I use, because I don't know t, so if I use this one, v squared u squared 2as, Vy is what I'm trying to find. Uy is, sorry, pointing off the screen, 8 plus 2 times minus 9.8 times s, which I know is minus 2. So Vy is going to be 64 plus 2 times 9.8 times 2, which is 39.2. Plus 64 is 103.2. So Vy squared is 103.2. Vy is the square root of 103.2, which is 10.15. And so on, which I'm going to store in x, because what the question's asking me for, if I get back to it, is the speed. So for the speed, I know that I've got Vx and Vy. Vx is Ux, which is 5, and what I want to know here is the speed and the angle the ball makes with the ground, which will be that. So V is going to be the square root of the square root of 103.2 squared plus 5 squared. So square root of x squared plus 25, which is 11.3 A2U4 which is 11 meters per second to 2SF, and then the angle for the last part, so the angle of the velocity the ball makes with the ground, is going to be inverse tan of opposite, which is Vy, over adjacent, which is 5. Which on my calculator is going to be shift tan of x over 5. So 63.79, 64 degrees to SF. And that's it. That's about as challenging as you're going to get in A-level when it comes to working with projectiles.